means to compensate the cutter or the radius of the cutter depends on the tools, because we said we have different tools and there is automatic tool changer. We change the tools depends on the required task. So in this case, for example, if we have a small cutter, it's not like the same as we have a cutter with a bigger radius. Like for example, for drilling, we have drilling with small diameter, we have drilling with a bigger diameter, we have drilling with a much bigger diameter, and so on. So each tool here, it has its own diameter. So sometimes this diameter will affect our measurement, because if I place the diameter, I mean the tool on the surface here, it's not like I place the tool inside the surface or in the middle of the surface and so on. So there will be some different in the measurement on the place. Is I place it on the left, I place it on the right, I place it on the top, I place it on the bottom, and so on. So it depends on the tool, depends on the tool dimensions, I mean diameter and so on. So this case, there is some code which compensate these values. I mean, when we do measurements, we need to consider the diameter of the tools. What is the diameter of this tool? Where the tool will be placed, from inside or from outside, on the top or on the bottom of the workpiece, and so on. So in this case, because if I place the machine is here, it's not exactly on 0, for example. So I mean, it's on the border here. So maybe 0.025 is there is a difference, and so on. So it depends on what is the value. So here there is 3 codes: G40, G41, G42. G40 is used to cancel any of the compensation. So no need, I mean, it's used when you want to ignore the radius compensation here. You want to cancel, don't need to use. And this radius compensation already defined in the standard of the machines. For example, inside when you do the offset of the machine, the manual setting for the machines, so you already consider. But if you want to cancel, you just go to cancel this by using G40. You want G41, G41 is placed on the left. So you can see here, this is G41 is placed on the left of the object from outside. Here it's placed on the left of the object from inside. Both we use G41 because it's on the left here. If you want to make the tool nose radius compensation to the right, that means it will be placed on the right from the outside or placed on the right from the inside. In this case, we are going to use G42 here. So this is how to write the format for this G41 and G42 is place G value and then X, Y coordinate with the value of D here for the diameter of this tools. Tool length compensation here for G43 and G44. The tool length here it's different that for the tool for different tool lengths. For example, I mean, if you want to do drilling here, so how long or how deep you want to go in the direction of the Z-axis, for example. So we need to define here G43 and G44 to identify the length of the tool itself, because if you have a set of lengths or a set of tools here, they do not have the same length. For example, this length is less dimension that one, this length is length. So how to compensate this difference between the length of if we work on the same workpiece? I have the spindle here. The spindle is the distance from the spindle to the workpiece is the same. But if I use the first tool, for example, the first tool is until here, the second tool is until this point, the third tool is until this point. So there is automatic tool changer. So when I change from small tool to the second tool to the third tool here, there will be a difference between the surface of the workpiece to the tool. So how we can compensate these differences? I mean, so this one depends on the machine itself, depends on the tools available in the machine, the length of each tool, and so on. Each company who developed this such CNC machine, they have their own user guide, which define all these offsets and all these differences in size, all these differences in diameters for each machine. Okay, so when the engineer come to do this definition for offsets, need to consider this one for the hardware devices. Then it will be programmed inside the MCU of the machine. The programmer can already this offset of these devices, either diameter or length and so on, already defined in the memory of the machine. So how to consider this such offsets? You need to use this program. I mean code for G code. So either for the diameter or for the length of the tool, all this will be considered. So need to add some values. I mean, in addition to the code, you need to define some offsets or length for the code. I mean, for the device itself. So as you can see here, these are different tools with either for milling, for boring, or for back boring tool and so on. You can see each tool, it has different size, and the different size here which make it if you have this is the part, you can see what is the value here. I mean how far these tools will be from the part itself. Okay, so also if you want to do drilling, for example, what is this the original point, this is the surface here, this is the offset value, how long it should go inside. And if this machine is with this length, if I say go for 5 millimeter, for example, it's not like if I ask this machine to go for 5 millimeter, because if I said this one go for 5 millimeter, it will go to this point only. So how to compensate the difference between the two tools? This will be done through the program here. So for example, G43 here, make the value of the cutter offset add to the value of Z coordinates. So the offset here will be added to the cutter Z coordinates. That means in the depth here will be add. Instead of go for example, for 5 millimeter, I will ask this one to go for 15 millimeter, this one for 5. So in this case, I will reach to the same result because I consider the difference in the length of the tools. For G44, also make the value of the cutter offset subtract from the value of Z coordinates. So if I want to add, I will use G43. If I want to subtract, I will use G44. If I want to cancel the offset, that means I do not consider any of this offset, I'm going to use G47. So this is for the format with, I use the G, I use the Z here, which is the depth, either plus or minus, and then I use the definition for H, which is related to the X offset, which already defined inside the memory of the CNC machine. And I told you this all things is most related to what is the tool that we are going to use, and all the information about this tool like that, because as I told you, there is a user guide for each machine, and in the user guide you will find a table. The table, it will specify the length for each tool, the diameter for each tool, and so on. So this will be defined according to the given user manual of the machines. Just here we need to know that if I want to add the cutter offset to the Z value here, I'm going to use G43. If I want to subtract, I'm going to use G44. If I want to cancel the all length offset or all length tool compensation, I'm going to use G49. So as you can see here, this is the actual tool here, and this is tool assumed during the programming. Why this is actual? Because this is what we have. This is the one that we have, and we know this length. But in the programming, if I want this tool, this tool to go to this length here, to go to this close point, and I need to specify the distance from the value of the offset here from the surface of our object. So I need to consider that the code in the programming is like this one, because the other tool is same like this one. So I am going here to add some in the Z axis, some like virtual or imaginary bar, virtual length extra on the original tool. This will allow this tool to go down deeper for this part. In the actual it's short, but in the program I will consider it deeper, so the spindle here will move depends on the program value. Can cycle. So the can cycles here are some of the constant cycles that need to be or that include some programs which need to be repeated. Okay, so for example, I want to make 100 of holes with the same depth, with the same diameter or same size. I want to repeat this say for many cycles, many times. So I have some of the part of the program, and this part of program just I am going to call, and this part will be repeated for many times. So when the tool here go to the bottom of the hole, for example, in the case of drilling, it will return back to the plane of R point and initialize the plane initialization by using G98 and G99. So G98 and G99 here will be used for the can cycles. And as we said, this used for repetition. For example, the drill go down to the workpiece, make a hole with this specific depth and go up again. Go to the second coordinates, make the same drill, or the drill will go down, will make the same hole with the same depth and go up again, and so on. So this is it's like will be repeated for as a cycles for many times in the one program. This is some example of the drilling and big drilling, tapping, boring, backspot fishing, and so on. So this all code that will be used. As I told you, the code that we list before in for the G code or M code, it's not all the codes. Okay, I mean we are not going to use all type of codes for G, because as we said, there are some many of the common codes between all companies, and there are also some companies they have their own extra codes. Maybe you will find G175 with G183 and so on. There are many G more than 100, for example. So these codes or this type of code depends on the machine, depends on. Sometimes they want to add extra command, extra functionality for the machines and so on. So they are going to add some of the codes. So here for G81 used for drilling cycle, G82 used for drilling cycle with dwell, G83 big drilling, right hand tabbing, and so on. All these type of cycles are used to be repeated. I mean, when you call it, it will repeat this. It will perform a task, and this task can be repeated for many times, depends on the requirement for the manufacturer part. So here it's a simplest operation. It's like the program as it's the program. I mean, this we are talking about the can cycle. It's the same definition here. It's actually, as we can say, it's like sometimes there is some we mentioned before for sub programs, but sub programs it consists from multiple codes. But for the can cycle here, it just consists from one code, for example. This is the difference, but the idea is the same. For the if you have the main program, you call the sub program. The sub program will accomplish one task and return back to the main program. For the can cycle here, it's the idea is the same, but this will be done through one code, as we said here. So if you want drilling cycle, just use G81. If you want drilling cycle with dwell, just use G82 and so on. So the command here will compress the G with X and Y coordinate, Z depth, and R clearance and F codes here. So this is how the can cycle coordinates or the can cycle program format will be. So this is the sequence of operation for will automatically occur when you call a can cycle, any of these can cycle. First is rapid move to the X and Y coordinates that you already defined of the whole center here. Then rapid move to the Z axis clearance plane R. Then feed to Z axis final depth. Then rapid back to either the Z axis initial position or the Z axis clearance plane R. Okay, so this is what is the sequence that will be done when you call any of these cycles. First, for the drill cycle here, you are going to move to the X coordinate. We said we are going to use G, and G here we are going to define what is the value of G here, which cycle we want to perform. G81, G82, G83, G84, whatever is the value of G. Then it will move to the Z axis clearance plan for R value here, depends on the R value. Then go for the depth, for how deep you want to make the hole. Sometimes if this is the workpiece here and this is the surface of workpiece, for example, and this is the thickness is like 5 millimeter here, then I want the hole here up to 1 millimeter only. I want the other hole up to 2 millimeter. I want the third hole at the 3 millimeter. So I'm going to define what is the depth of this hole. Okay, according to this value here, the final Z value. Then after you perform this drilling, the drill or the spindle should go back again to its original position. Okay, either the initial position before do the drilling cycle, or the clearance plane R, or the R value here that we define in the program. So the program only needs the next hole coordinates to perform the same operation. No need to do any other coding. Just define the coordinate for the next hole, because this cycle, for example, to make drill. So for example, this the one G81, it will make drilling cycle. So just what I need to define, I need to define where I need to perform the drill, where I need to place the hole. So how to place the hole or where, just need to define the coordinates for this hole or this place. Later on, we have some example about this can cycle in the next chapter, okay? So as you can see here, for G81 is a can cycle for drilling hole in a single drill stop. So here you need to perform drilling by using this machine or this drill here. This is Z initial position. This is the value of xn, yn, and also r plane. Okay, r plane here, and this is the offset value from the original surface here. To define the value, or I mean, what is the difference between this point when start drilling, okay, until the point here is the initial position of the spindle. So need to define this coordinate xn, yn, and also zn. How deep you want the drill to go inside the body of or inside the workpiece. So zn here represent how deep is the hole, okay, and xn, yn represent the coordinates of the hole, of the center of the hole here. For example, if you want this like diameter here, so you want to define the center of the hole. So this will be the center by using x and y. And initial position here is the position when the drill start or stop. When the drill come from previous point, it will reach to this point to perform hole here. So before it will not go directly to the make drilling. No, it will stop here for a while. Then it will go down until the R plane position. Then start do the drilling for this depth offset. Okay, so this is the form for drilling drilling cycle, drilling can cycle, which is G81, for example. The G81, xn, yn, this is the coordinate over the center of the drill which should be placed. Zn is the depth of the hole that we want, the depth of the hole that you want to perform. Rn and Fn here, Fn is the feed rate that you require the movement of the spindle go in the body of the workpiece. Then you have the Rn, which is the definition for the clearance for the surface here, which is of the R plane. Okay, so from this point, it will go by feed rate of like this speed into the body of or into the workpiece that I want to drill. So this is another example for to define the drilling cycle, which is G81. So you need to define, as we said, this is the code here, G81. This is X coordinate, Y coordinate. Here is the depth is -1. -1 because if we assume that we are working in the X, Y plane, so X, Y plane, we said one of the main advantage to use X, Y plane here is allow you to easy calculate under the plane will be the negative Z, because if the Z is on this axis here and this is one X plane, so under the plane or under the workpiece here or under the surface of the workpiece will be defined the Z value in negative. So this will be the Z here -0.1, and what is the clearance is 100. I mean R is 0.1 here, and F is 1.5. Then next, you want to make another hole, you just go to the next coordinate. No need to redefine all these things here. Just you define the next coordinate, x, y. It will make the same depth, which is based on the value of z. If you want to make like 7 holes or 6 holes here, so this 6 hole will have the same depth because you already defined the depth is -1 here. So no need to redefine again. Just go ahead, define the next coordinate, the third coordinate, the fourth, the fifth, and so on until you finish all hole. They will perform all drilling cycle. So it will feed to the depth that you define, which is -1, then rapid return to the initial position of the Z or into the place of the R plane at this surface. Okay, then you want to stop this one, you just go for N38 for GET, so to the end of this or to the end of this cycle and return to or stop the cycle of drilling. This also we have some of the, I mean, the G code that we do not talk about it until now. We are going to use it directly with the coding that we will be used for either for lathe machine or milling machine in the next chapter. So in the next chapter, we are going to continue about the same topic, but it will be more structure on building the complete program, not only to give examples about each code. Okay, so we're going to talk about lathe, I mean, either programming for CNC milling, programming for CNC lathe, and so on. So it will the one we do not have or we do not highlight in this part, we are going to highlight in the next chapter. Now we are going to highlight some of the commonly used M codes, and we said M codes more used for miscellaneous functions. That means I want to switch on, switch off for some functionality of the machine or for coolant system, and end the program, exit the program, and so on. So we are going to use the M code here, just to make it different from the G code, which is preparatory functions. So this is the form of the, I mean, the program. I mean, the M, when we use first is M00. So it's more on program stop. The M00 code is used to stop a program. So if you have a running program, you want to stop, you just add, I mean, in one block, you add M00. That means it will stop the program from running. You already execute the program in the machine, you want to stop it, just make in the program M00. It also stop the spindle and turn off the coolant and stop. It's like emergency stop push button for the machines. Okay, just you press, it will be stop all the related machining part of the CNC machine. Okay, how to write it is like N with the number of the block, then M00. Then we have M03. It's more on the spindle on either clockwise or counterclockwise. So if you have M03 here, if you want to run the spindle clockwise, or you see, don't confuse between M03, M04, and G03, G04. G03, G04 is more on the movement of the spindle, not of the rotation of the spindle. But here we are talking about the, I mean, the spindle may be rotate and move at the same time. So when we say G02 or G03 for the circular movement, either clockwise or counterclockwise, this is the whole, the spindle will move. But here only the spindle will rotate at the same point. So M03 and M04 will be used to switch on the spindle to rotate for drilling, for example, for milling, and so on. So it will be rotated either at the same point clockwise or counterclockwise when we use M04. M05 here is more on the to turn the spindle off. I mean, we already ran the spindle clockwise or counterclockwise, but then we want to make it off, stop, so we can use M05. Here we said, although other M codes which turn off all function like M00 or M01 here, which make off all function. This command is dedicated to shutting the spindle off directly. That means M05 is more specific to the spindle only, while M00, M01, no, it will be switching off all the machining part. Okay, the M05 command here will be appear in this part like M number and then M05. So for example, here we have N5, G90, G20, okay? Then we have N10, M06, T10, already spindle, then go until the end of this, I mean here we change the tools, we go until the end of the program, then we make N65, M0. At the end here, M05 will stop the spindle only, not stop the program, not stop the other part of the machine. M06 is used to tool change, as we already mentioned before. We said each machine it has automatic tool changer, and this automatic tool changer will change the machine tools. So, for example, I am using the drill with the length of 5 inch, for example, 3 inch, 2 inch, and so on. So it depends on I want to this diameter. I want to use drill with different diameter. I want to use uh, or the spindle to change its tool for this point. Then I use it for a while. Then I want to change to other tools. So I'm going to use the M06 tool. M06 with the letter T. So this will be used to change the tool here. M06 T2, that means I'm going to use the tool number 2. M06 T3, I'm going to use the tool number 3, and so on. So as you can see here, tool change to tool number 12. I use M06 T12. The main thing you need to consider that only one M code should be in the block. I mean, you cannot see M in one block. In the program, yes, but in one block only, you only need to have one M code. You only need to have one feed rate. You only need to see one speed in one block. Okay, so there is no repetition. But for the G, we can see. You can see here we have G90, we have G20. We may have G291, we have G21. We may have G01 with G90. I mean, we may have some of the duplication, or I mean, some of the not duplication, some of different G code on the same block. But for M code, each block can only have one M only. No repetition to using M in the same code. Whatever M same or M different cannot. Only one M for each block. M7, M8, M9 is more on the coolant on and off. So M07 or M08 here is used to switch on the coolant. We said we use the coolant here to cooling the part of the machine, like the spindle, the head of the tool, and so on, because you know when you make like steel on the steel and it's rotating, the spindle, for example, is rotating on the steel or used to cut the part which is steel. When you have two like metal or two steel machine and so on, the temperature of the tool will be very high because due to the friction between the two surface. So we need to make this coolant either to lowering the temperature of the machine, I mean of the tool. When we lower the temperature, we increase the lifetime of this tool. Otherwise, if you use it and it's got very high temperature and so on, maybe you use it 2 times, 3 times, 4 times, it's broken or it's already damaged. So for that, they use in the CNC machine, they have to use a coolant, and this coolant will spray some of the liquid to lowering the temperature of the tool. So for example, we have M07 and M08, both they use for switching on the coolant. M09 command here is used to shut down of the coolant flow. The coolant should be off here prior to the tool change. That means before you go to change the tool, you need to shut off the coolant by using the command of M09. M30 used for program end. So you build your own program. The program, it has initial, I mean the indicator for starting the program. It has the program number here. There are a lot of blocks in between. You come to the end, you want to end this program or reset to start another program and so on. So use M30. So N90, M30. So M30 will end your program. So the program will execute one time until reach to M30, it will stop. You want to run it again, you just go to execute again the program. Block sleep here, it turned on upon the execution of the CNC program. So this one is like the block, the program will ignore and CNC code on that block. So for example here, if you know in MATLAB, for example, sometimes you want to add some you have some code, but you don't want to use it for this run. You want to use it later on. So you want to comment this code. You don't want this command to you don't want to delete. You want to keep it in your program for future modification, for future running, for example, and so on. But you don't want it to be executed. So you just need to add this block before before the block, you need to add this sign before the block. So that means these two lines here will not be executed. If you have this sign before the line, it's like you as we said, but I don't want to say to comment either. In other programming language, they call it to comment this code. So here it's not because the comment also we need to add some definition to define this active code, for example. I can use comment also here to write what this means. But for this one, no, this will be totally stop running of these two lines or these two blocks. So in this case, we use this two, and this is considered as under the M coding. So all the code after this sign will be ignored and will not be executed. This is the comment statement here. Comment need, for example, you have a code, but you want to write some comments to explain what this could do, what this block of code will do, what this code of block will, what's the benefit from using this code, or to explain the details of the code. So you add comment statement here. How to add comment statement? You need to add bracket here, and inside the bracket, you just write what you want. This will be like explanation. It will not be a part of the code. It will not be executed, just for the programmer. The next time you come to program, or there is someone who want to use this program, when he read this comment, he will understand what you mean by your line of code, or why you use these parameters, or why you use this coordinate, and so on. So this is to define the comments for your program. Here, this one example to show like a complete some of the complete program, which includes some of the M code and on the N codes and so on. So the G code, N code, M code, all this will be used here, starting from the first sign for the start the program start flag and numbering, and go on through the feed and use M code to the stop the program or to end the program. You use the M for spindle on and off. You also use the M09 for coolant off, you use the coolant on, and so on. This one for M08. So it's just to show you how you can define different part of your program. So this is how maybe your exam will be, or your test, or maybe in the future will be. You will be given such graph or such drawings, and you will be asked to develop such program, G code. But in addition to this graph, you will be given some information like description. Okay, in the description, we will state what is the feed rate, what is the diameter of the tool, what is the speed, spindle speed. Okay, maybe some of description for this figure. Okay, so based on this description, you are going to define your own program. I am going to highlight this issue here. There is some issue in the manual part programming. because the manual part programming is more adequate for the simple jobs or some simple point-to-point drilling. Okay, so I mean, manual part programming is not preferred to perform the complicated task. So if you have simple job which has linear interpolation, for example, circular interpolation, cutter offset, and so on, so it's easy to use manual part programming. I mean, directly input the manual or the program manually into the MCU of the CNC machines, so and then execute the program. But if you have more complicated program or more complicated drawings that you want to develop CNC for, I mean G code for it, so it's better to go for one of the other available type of programming. Okay, so manual part programming is suitable for the simple task, but for the complicated one, you may go for example, computer assisted programming, CAD CAM programming, and so on. So this all will make easier because you have the support from the computer software. So most of the software, like the software that I told you, is provide functionalities to convert the existing drawing directly to the G code. So why we need to waste our time to develop the program by using manual programming? Because this one was not available last time. I mean, even in the beginning of the CNC machine, people used to have manual programming. Later on, when they developed the software which interface between the computer and I mean between the human or between the programmer and the machines, then this software, I mean, people start to switch to CAD CAM programming. So if you remember in chapter 1, when we make the evolution of the NC or numerical control system, we highlight how we start with the NC, then go to CNC, then go to the direct programming, I mean the direct numerical control, distributed numerical control, until we reach, then go to the CAD, go to the CAM, then at the end we come out with the CAD-COM or I mean manufacturing aided, computer aided, or I mean CAD and CAM, combination of both CAD and CAM. So for the CAD and CAM, the people will develop the CAD, or the designer will develop the CAD in the 2-dimension or the 3 dimensions graphics or drawings. Then these drawings will be converted into a G code, and directly by using the software, and this G code will feed to the MCU. Okay,